Guys, let's go because
Yeah.
I think it seems that we should.
I think we have a meeting. Yeah.
No, I mean we should to have one. I mean 10 minutes later. Finish. We have to finish 10 minutes.
We
So
have finished 10 minutes?
I mean 10 minutes later. Not in 14:10, but 14:20. Okay. So today we have two topics: Newton-Euler and Lagrange equations. So the first one I will give it because it's I give you some intuition on how to work with it. Because actually you won't use it during this course, but as I told you before, it's using in gazebo and other computational stuff. And Lagrange equations you will have it on midterm. About this one, I will give you. My final, sorry. So actually, our class today is lecture-like because I should solve two tasks. As you may see, I already prepared nice sheets. And you will learn how to use Lagrange equation at home. So you will also have it, 1 week home task. Why I did it like this? Because you have the next week. So the next week weekend free. We just have one class on Monday, and after this.
Which class? Lab? Just
yes, lab, exactly. Okay, yes. Because we need to summarize all our course in one day. And after this, you have time to prepare to final. So you need to get how it works with the actually it will be all course will be in the final.
Yeah, we will have for example, 2 questions, statics, 2 questions, or 1 question, 1.
4 questions, if I'm not mistaken. 1 will be on Lagrange. I already made on Russian actually the final, because on the previous year everybody was from Russia. So yes, and we have.
Check your translations twice because sometimes you the last homework you translate it into English. It has some troubles. Okay. Some conditions are missing. And so.
In this case, you can say me the mistake, but I didn't receive it.
I managed to figure it out because I have the Russian.
100 kilos. Who cares about 100 kilos?
Yeah,
No one cares about.
What do you mean about 100 kilos?
I sent you a message
about
that you forgot to add additional
conditions. Yes. Okay. So actually, yes.
If you, first task,
as you know that I made this.
Seaters.
As you know, I made this course from the scratch. In the labs because on previous year it was very bad, much worse than this one.
You can give us tasks from final, so we can examine translation.
No. Okay, don't worry, guys. Today we have quiz, 10 minutes quiz. Because we need to. It will be.
Траектория была нормальная, но 12 километров.
It's about the previous topic.
Same question.
No.
It was about Red Bull.
What?
Red Bull energy drink.
Nice to
Give
meet
you.
You got sponsors for your.
Thanks to our
The no
sponsor.
idea appears in each event in Innopolis and give it for free.
What?
Yeah. Also, one time we came to our lecture and there was a girl who studied with me at school in Kazan.
And я такой, okay. I see how that goes.
Did you see this guy, this girl with a backpack?
They
looks like a drug. They want one for free.
I think they came for ITP2. I think, or one lecture.
Came to Иванов.
Linear
algebra.
Yeah.
Linear algebra tutorial.
I think no lecture.
Иванов.
Иванов нас присутствует.
He wrote Red Bull зло on the whiteboard.
Yeah, that's fine. Torkov moment.
Torque doesn't produce force. We have to remember on the
Constant Torkov moment. That's something new. Never heard. Constant Torkov moment. That's something. Okay.
What is?
Don't worry, I didn't. It was my translation.
Okay.
We don't worry, nice.
It's from Mещерский English book.
Torque of movement.
Torque of movement. I guess it's just torque.
I know, because this is just translated from Russia. So the quick moment, momentum.
And on B there is like a quotation. It's what?
It's conveyor.
Yeah, no. The object B. There is a
B is,
notation.
closer to
Because
the-
of torque.
Yeah, there is like what is that symbol? Beside the arrow.
Alpha angle.
Alpha. Ah.
We have on the torque there, I mean.
Yeah.
Yes.
And the other is like following it.
Yeah, because it's built right.
Draw a scheme and put all forces where. So it's a part of a task. Looks like our physics final.
Oh yeah.
Oh my.
Draw a picture, you receive 1/4 points for this. Or 1/2.
Well,
1/4.
In our case, if you didn't put the formal criterion and it didn't highlight the answer, you have minus half of the task.
Oh shit.
It's a pity Vika received 9 out of 20 on the midterm because of it.
what?
Ah, no pity. What is mass M2? Why M2?
Was
It's big of each
pulley.
pulley.
And in each pulley, like in each joint, you have like reaction forces, right?
In all forces. I especially put it, and in the second part I also put even is equal to 0.
It's what?
So even if work is equal to 0. I especially put it there. Because for one task, it doesn't matter that you don't have, for instance, about reaction force. In some cases, it's
Okay, so
if
we-
you forgot about reaction force, it's okay. But in some cases, it won't be.
So we assume that there is a high static friction and this conveyor just drags the body A
Yes.
without slipping.
Actually,
So we can say that the force produced by torque M, force produced by torque, is attached to the body A.
think
I think like this.
right as you want. We will discuss after the. That's right. I didn't get the network. Means more. Actually, because time is over, but
Защупите, долго написал.
it's the last quiz. It's the last quiz.
Last quiz,
On Monday we won't have any quizzes.
but we have informed Moodle.
I just dropped one. It will be 9.
There's only 5 years.
If you really need one quiz, I can make the last one if you want. For 5 minutes. That was the previous one. I mean, previous one. 1 minute left.
Will a body have velocity?
Go. Are you ready? The end here. Where is the works? Okay. So, вон, хватит сидеть системой. Go. Drop time.
Greenpeace will be mad on you.
Agreed.
Where are the highlighted answers?
Who cares about everything? It's not final.
It's not final.
Okay. Let's go solve this task quickly. What we have? N agree? Two reaction forces, and there's two reaction forces. We have torque. That's it.
And what about gravity?
Ah, okay, mg, of course, my bad.
And also the force produced by torque,
Huh? Where
which
is it?
will drag
There
the
was
body.
You don't need it.
Ah,
Because if, so,
Actually, like, I missed that there is alpha here because the camera. No. Yeah, this I don't see it from here.
Ah, he changed coordinate frame.
yes.
Can we say that so work done by this torque is like final kinetic energy for these pulleys and kinetic energy and potential energy for body
The window is open. Okay, so we have
You might go.
mg1,
A?
mg2,
Switches to-
mg2, again, it will be the same force. Okay, let's write it. 2 mgs.
подожди.
Not now, wait.
We should stop recording first.
Rx, Ry, Rx, 2.
Ну или хотя бы как какой-то.
The TA made that somebody decided to drop out of the window. Okay.
Wait, don't do it. No, you can.
Yeah, you can. Okay. After this, we need to say about work. Will it move? No.
No.
0, 0, 0, 0. This guy. As you remember, we can so the job.
So I didn't get the point of the reaction force. Why it is zero?
It's not force, it's work of this force. It's
I-
zero because it doesn't.
I mean, I wrote all
produce
forces. I wrote all forces, and now we are talking about
The work.
yes, A of it. Let's write like this.
No.
Yes.
Why
Of course, it
not-
won't be equal to zero. What?
Why not delta or sigma?
Okay.
It is this one.
What person?
So you wrote delta A, yeah.
Господи, R равно F на S.
And A is the work.
Я думаю,
Or for angular, we can write it in this manner.
Who needs this delta A? Nobody knows what this is delta.
So we have, we know this is Wisconsin torque, and we know so. I mean, for M it will be M T. This is rotation, some rotation. For instance, we know that. What we actually, it's not about us. So actually, in the real task, it will be provided. Okay, this one. We can write either mgh because it's potential force, or yes, potential nature of this force is
Delta
potential.
H.
Delta H, yeah, thanks. Actually, I would like to say that pi minus pi 2.
Yeah, that's
Yeah.
how I write.
Yeah. So in this case, you can write either like this, or for it's the easiest way for this, or we can go. So M2 won't make any movement.
Why? I don't get it.
Yes, because M won't be changed, so to 0. And this one, yes, it will make. I forgot 10. Sorry. What about 10? Will it?
Yes.
Are you sure?
We have some Y movement and some X movement. Yes, we have. It's conveyor.
See, N
So,
S cosine 90 degrees. Because N looks like this and movement like this, it's equal to 0.
тогда по Y будет. Вот. If we have chosen axis like this,
The equation, I wrote it in this form, but in real form it will be F S cosine, the angle between F
S is
and
vector.
S.
S is vector.
I can put S like this.
S is vector.
Yes,
Yes,
but my
no,
X,
no.
I decided my x-axis will be like this.
Yes. And according to our axis, it will have displacement.
You don't. A work is not dependent to axis.
On force and displacement. Displacement is dependent on axis.
Two forces.
Yes.
These
No,
two
S is not force. S is displacement.
You only care about the angle between them. That's it.
angle.
This is 90 degrees.
So it's equal to
Ой,
0.
Я
Just
согласен, что оно на Y твое, которое ты выбрал. там
нет.
Что нет?
In general, you didn't get that force vector doesn't depend on the frame. Is the force depend on the frame? No.
Direction depends.
I ask the vector, the force. No. See, the coordinate is depends, but the vector itself, no. It was from linear algebra. I explained it in the last class, actually. Your force doesn't depend, so you have this. It won't change. It will be in this direction.
Well, first of all, the reaction is produced by mg. By mg cosine. Что ты говоришь? Зачем вообще мы находим работу n, если она будет равна минус работе mg?
Because you have. I see. Open the, for instance,
Хорошо.
you didn't get stopped. It's the problem of internal and external forces.
We have this. Assume it moves to this position. We assume. It has some force. It also has some force. We have some displacement. We chosen like this, x, y. So according to x, it has some displacement like x0, x1. So it will be this. And according to this, it will have some y0, y1. So this force multiplied by delta y will have something.
The problem is that you are talking about different step. I'm talking about via, it's a vector, not coordinates. So it doesn't depend on coordinate. You are not when you write for
But it's non-zero vector. It have some displacement. Like S.
and it will be like this. And you know that angle between this one and this one will be equal to 0. I mean to
You
90
agree?
degrees.
It's a vector.
Yes. This
Non-zero.
it's coordinates. It's coordinates. Yes. I agree. But angle dot product between this guy and this guy will be equal to 0 in any case. Because your force have only one direction. Of course, we are not talking about right
Why
hand.
here it's cosine?
Because the actual this equation is f cross cross product s. Oh, dot product. Sorry, dot product. Dot product. Yes, but an angle between this because it's dot product. It's not just multiplication. It's dot product. Open the how to derive a, and you will get it. Actually, in the previous lab I explained it. I mean I put the all formulas. Open a lot of lectures. They have a derivation. How to derive this one. Sum up. Works doesn't depend on frame. You're operating with vectors. It's the reason why you're only operating with vectors. Yarek, if you have problems, you can go to office hours.
To what?
Office hour. You came to me once, you two, and you two Henny. So you can do. I don't know that you will fail on final.
Что? Fine.
See, I don't want that he'll drop. I don't want it. Because you think that.
What about me? I have C already.
Okay, so now we're talking about the next, guys, pay attention because it's quite important. This is the reference which I use for the next. Actually, today, I mean after the class, till this week, I highly recommended you to open these two guys and at least understand what's going on there. The problem is that actually in theoretical mechanics, do you know what does it mean Jacobian? No, most of you. I mean at least, do you know the Jacobian? What is it?
Jacobian matrix?
Yes.
Yes.
I mean, matrix Jacob in Russian, yes, but what is it?
It's like matrix of partial derivatives.
But what is it exactly? Why it's paired?
What we should find, so we use it to maximize.
Actually, it's just a matrix which helps you to go from one space to another space, but your space is not linear.
Like in a
So you have, for instance, I mean, it's the difference between joint space, for instance, in manipulator angles, and Cartesian space. It will be V and omega.
From
It's a range.
Cartesian to polar coordinate.
Not polar. It's a generalized coordinates actually to this. Now we
Yeah.
will cover does it mean generalized coordinates.
So that explains it.
Yes.
And we will just take it more fundamental for what.
Yes, it will be. But the problem is that, how to say, we will solve all these tasks today using without knowledge about Jacobians and so on. But in robotics, we used to work with matrices. When you will code it at home, it's easier to make using matrices. But if you don't want, you can just do it without it. So in general, there are two explanations. One from robotics. They are not trying. They have some very fancy techniques, like to make it, how to say, squeeze to just receive two free matrices. In theoretical mechanics, we will make 9 steps. So to solve the task, we will do 9 steps. In robotics course, it's not so much because they just, how to say, derive it in very fancy manner, try to, I don't know, to make it squeezer and so on. If you want, you can go through this and get how it works. Also, I recommend you to open my later slides to get how to derive Lagrange. Probably Palestine already explained it to you, but as I get that you didn't get what's going on. Yes, Henny? Or you know how to
Guys,
derive?
just practice. I didn't study it.
Okay, so just spend time because it's really important. It will be on your final.
So we will have Lagrange, but not Hamiltonian.
No Hamiltonians. Yes. No relay functions and something like this. Why are you so pity? You was
No.
relay function in the
No,
final.
I didn't study it, so I don't know that.
Ah,
We studied it today.
Did you understand?
relay function? Relay function?
Yep, today.
Okay.
For
It's about
the
functions on the torques, yes? How did he explain?
No. He.
The legend.
The gender transform.
And after the gender transform, we
Gender
saw this resistance.
Relay.
Yeah.
Relay.
Some weird stuff.
Actually, it's you can put some frictions on your motors and so on using these functions. I briefly just for practical purpose. Okay. So, do you know what does it mean generalized coordinates?
Yes.
Okay, so this task we have so can you say me the generalized coordinate for this guy?
And also,
It's just the argument.
Yes, there are. Okay, two angles. That's it?
What is on the end?
It's an effector.
So we will.
it should. Yes.
No. Just
That's
one. No, 2 degrees of freedom, it's okay. Can we find other generalized coordinates?
That's one.
As long as we know the length, so we have the end effector point.
Nice. X, Y, and effector.
But
I didn't ask you is it efficient or no. I asked
to describe the system.
yes.
Well, usually you don't know it's y by the factor, you know the fixed point.
Like you know
Point where you-
the lenses, and then you just like make a
Yeah.
transformation from this frame to this frame, and that's it.
In this case, you need to do the inverse kinematics, not forward.
No, first.
Because you operating actually in robot you're operating with angles, but if you decide to make general coordinates like this, you need to make inverse matrix to find these angles, because otherwise it won't be have any sense.
We know angles, we should go to this way. This forward one.
You don't know angles in forward dynamics. Actually, it's not correct to use forward dynamics in inverse dynamics.
That's why.
In Russian, it's called the first problem and second problem of dynamics. And actually, in this case, when we solve the plane of motion, we solve how to say inverse dynamics, not forward. So it was mistake in the previous class.
Which is
Do you remember when I said that from? Yes, actually, we're solving inverse dynamics, not forward dynamics.
so inverse dynamics when you know the position and you want to get the forces.
It's forward.
Okay.
Actually, in Russian they have the first and second.
In last lab you said.
I said that it was mistake. And as you remember, I say that I don't remember the precise names, but that we have one in one direction, another direction. I remember that I
Like
can.
when you say that integration is going down, I suspect something is wrong. Integration is going higher.
Okay. So we can find points. Can we take q1 and x and y, for instance? Let's generalize coordinates. Yes, we can, because it's two independent
But
parameters.
are they independent? How to prove? Who knows?
But are they sufficient to describe the full
No, 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 are they independent? If they are independent, they are sufficient.
Yes.
Q1 and Y? What's Q1?
The
q1
angle and y.
and the coordinate of n
I
effect.
don't think they're independent. Because changing Q1, you will change y.
Yeah, they're independent.
Yeah, dependent, but okay.
But only
It should be
the
the-
condition is just if they are independent.
Yes. The condition is that you can take whatever. It should be.
Yeah, but for
Independent.
example, okay, if I
They
if I-
should be unique because you need to.
Yeah, if I have just system of two independent, but this two independent will not be sufficient to describe the whole system.
But like
You have how many degrees of freedom do you have?
Okay, so it depends.
We have
also
2 degrees of freedom.
The number of degrees.
Yes.
See, like constraints, we subtract constraints.
Yes, with the constraints, yes. So you have 2 degrees of freedom, so we should have 2 parameters. It can be more, we can specify 5 or
But
6.
they will be
By the
dependent.
dependent, yes, it doesn't have much sense. And also I try to explain that in some cases it's better to choose, in manipulator, yes, it's obvious to take just angles, because actually we are controlling robot uses angles. But even this, we can take this one and we will have some problems, because we should solve inverse kinematics, because actually we have only angles in real life. I mean, we should find angles, because if you decide that to operate with this, is a problem.
And here in 2R we have 3 particles, right?
What do you mean particles?
According to n part, that's a system.
2.
2 or 3?
Yes. 3 independent parameters. So.
No, the big N, I think. I mean.
Big N is number of particles. The L is
Yeah.
number of constraints.
We can count actually. So we have
1.
2. So particle probably.
Is joint.
S is the number of joints.
2 particles and
Yes, number of joints.
or 3 particles.
We have 1, 2. We have 2 joints. So
2 particles, 1
You get something wrong because we.
L should be 4. L should be 4. So it will be ground.
Why 4 constraint? Ground. I thought only
So
length.
N is particles. Yes.
Mm-hmm.
So N should be 2. So 1 second.
Why we have 4 joints?
It's a good question.
It's not joint. Joint
L.
joint, this is particle.
What L? L is.
L is constraints. Why 4
How
constraints?
many constraints?
The
L.
length between them is 1. 3 hours.
You have ground and constraint.
Okay.
By the way, it will be explained in the next semester, because it seems that it looks like the Chebyshev formula, so Grubler formula. But actually, I can show it on the. I know. I can explain why it's 4. Because rotation joint, how many degrees of freedom do you have in one joint?
1.
1. We have 2 joints, two constraints.
Why?
Because you cannot move along x and along the y axis. Do you remember the traction force on pin?
Okay.
On this guy? When we have some.
When Poletkin presented this formula, it worked simpler. We
So,
managed to calculate it.
how many amount of actually Newton Euler will explain this part. He will go later.
Ньютон Сейлер таки так тут и формула.
Generalized forces.
Okay.
How can we find? Actually,
Oh,
there are some formulas, but actually we can
Just for notations, what is Q?
Q generalized forces.
Okay, what is A work?
A work.
And Y is is what?
What? Pi?
Pi.
I explained this potential force.
Okay.
Small q is angle.
No, it's generalized coordinates.
And what is big Q?
I told you, it's generalized force.
So small q and big Q.
It's common. It's you can find this notation in other books. Actually, yes. Now we're going to approach it between dynamic modeling. Wait.
1/IQ.
We have analytical mechanics.
IQ is below 0.
It's this guy. Oh, it's this guy. Lagrange.
What?
Lagrange. Actually, it's Lagrange, Euler-Lagrange also. It's not just Lagrange. We can call it like Euler-Lagrange. So, Newton Euler. You may see that Euler decided to be everywhere. He just go, okay, guys, I'm
You
here.
know Arnold's theorem.
So, as I told you that it's called energy-based. Why? Because actually we need to take derivative from energy. Is the reason why we call Lagrange energy-based. This one, actually, okay, we will explain it now. You may read it. It's better to read it home, actually.
Okay, let's go. Let's straight to the task. Apply our new knowledge.
Lagrange Newton-Euler.
I see some Stanford materials.
Yes, of course. I wrote that it's from Khatib's class because I learned that.
Credited on the slide.
You may see that I put credit there. So, actually, I will explain it on the next slide. Just know these two formulas and Lagrange. You may see that some MVG. We won't use this notation during the theoretical mechanics, but in robotics it's common notation.
And
What is Russian called the Newton's second law for rotation is Euler formula. I see.
And what is n? N should be n.
Torque.
Torque.
It's called in Russian. It's called the second Newton's law for rotation. I saw it in Rizas materials.
Or we can call it angular momentum.
Yes.
We use it on actually if we use both of them, Newton-Euler. In this case, we actually receive the whole the theorem of whole dynamics of the system actually. But in one case we need to operate with generalized coordinates. In this case, we don't use it. But in general, that in 3D we can receive free rotations, free torques. Torque equal to this one. We did it on the two classes before. And linear. Actually, what is it? The linear momentum. The coup de terre
derivative.
equal to two forces. It's this
It's
one.
not linear. It's derivative of the linear.
Yes.
That's the kind stuff.
But actually, it was two, the derivative in real. I mean, in original.
No, linear momentum is mv, right?
Yeah.
And derivative of it is ma. Force. So,
I need to open the. I'll open the slides from previous.
You told us force is a linear momentum. That's not correct. Force is a derivative.
Derivative of linear momentum, yes, but I mean that it's equation that's of the theorem of linear momentum of the system. It's this equation. You can derive the whole. You can.
Оно не
See.
доходит. Слишком сложный запрос для Google.
another slide.
So we can represent our motion, 3D motion, using these equations: free of translation and free of rotation. The first free as a statics. Do you remember in static how we solve it? But we equal to 0. In this case, we have forces, so we cannot do it like this. But general, so linear momentum, derivative of linear momentum. Yes, yes, because it's ma, but we represent it in a different manner. And when we're talking about rotations, it's torques.
Yeah, I have a question about this. So this equation, if I understand correctly, when we have inertia frame, we will have this term like 0. Like we would.
Yeah.
Yes.
Cross product will be 0 because 90 degrees between omega and omega with itself. Like dot product of IC and omega will be perpendicular to dot product.
Cross product.
Cross product will be 0.
Okay.
I like why exactly it's better to refresh.
Okay.
Case study.
Yeah.
Now I will explain. Actually, do you remember statics? When we solve the task, when we have a lot of joints and we separate it on the joint and solve the equation. The same exactly solution. We representing in our body and write the whole dynamics. I mean the free momentum, free acceleration. I mean free torques, free accelerations for each body. And we can solve it independently. But we need to put constraints. So in this case, we have how many degrees of freedom? We have 1, 2, 3. So we have 3 degrees of freedom. So 3 on 6, 18 equations. Just 18 equations just for explain each element. After this, you need to put constraints. Remember how to do these constraints? Because when we try to solve in statics, we put, okay, we have 2 forces there and 2 forces there. And if it's joined. Do you remember this? Reaction forces. Four constraints. Or 5 constraints.
Two constraints.
In 3D. We are working in 3D, don't forget about it.
And Wi-Fi.
So just 3.
So we cannot move it along the X, Y, Z axis. 3 constraints.
It's considered.
And we cannot make torque, rotate around 2 axes. So for this joint, we have 5. For this joint, we have 5. For this joint, we have 5. Okay, 1, 2, 3. We need to write it for 4 bodies. Sorry. 3 multiplied by 5. 15. And I can solve this. I can put the systems in MATLAB or whatever and solve it. Of course. How it will look like, these constraints? For instance, a constraint about that it cannot move. x1 equal x2. Yes, very complicated constraint, but it appears. So, x2, y1 equal y2, y3 equal y4, and so on.
But wait, when you put constraint, you put it for the joints, right?
For joints, yes.
You don't manage. You don't deal with the rigid body, the center of mass, the rigid body. You just like work with each joint.
And now you just see in statics. Did you operate with this part? Did you operate with center of mass and so on?
No.
So now you do the same technique. You just separate your body. You assume the left part and left part. Do you remember? When we had assume that we have one joint. We write 3 equations for this guy and 3 equations for this one. In general, it will be 6, 6. But because we put constraints, we can receive one more variable because of 5. Actually, the main goal of this in computer, you can either write like this or use recursive form. We won't cover it now, but you need to know that it can be solved using recursive mode or recursive form. It won't be on the final, but I just to show you the possibilities, so how it works. If you want to dive in, I provided all material. Just look, go to each, try to calculate, compute it on the computer, solve it or solve some case study, and you will get it. It's the reason why we are not covering Newton error during the theoretical mechanics, because you need to solve a lot of equations. You don't need for this. Now we are going to Lagrange equations. Neat equations. There are 2 possible. So do you remember there was in Lagrange? Why it's called Lagrange equations? This Lagrange. So kinetic energy minus potential energy. and we take derivative. What the difference between these two? In theoretical mechanics, you will see only this. Most of the time, you will see this equation. On robotics, this one. Do you have any ideas why?
It's related with potential.
The first one you don't consider potential.
No, Q consists of both potential and non-potential.
Non-potential forces. It's really
There. Now it's not potential forces only, non-potential. Why it's in robotics? Actually, you can use both approaches, no problems. Why it's appeared like this? Because in robotics mainly you're writing dynamics to control something. What do you in manipulator? What will you have there? Torques. Torques is non-potential energy. I mean non-potential forces. In this case, on the right side, you will have both torques and some masses and so on. It just depends on notation. I mean, not notation, but I mean, how can you use it? In linear algebra, it doesn't matter because you can do a lot of approach. In my in my sheets, I use this one. The algorithm is following. First of all, we need to write as usual research object, motions, degrees of freedom, force analysis. Let's do it. Research object.
Can I ask you a favor? Please check if camera. There is also a problem with 11th lab or 12th lab that no sound
Who cares about
on YouTube.
Here.
But
Here we see the sound. Ah! Yes, sound is again.
it seems so. I hope so. Okay. So on the last lap, will be in 11th. Did we have the sound?
No.
Let's check for now. Let's check it.
We can stop about that.
Yes, in this case we have two videos and I need to scan it.
So them stating right
Nobody once told me the sound is gonna
make it.
Okay. Guys, let's go because okay. Guys, let's go because you cannot because it's zero. I mean,
It's zero?
I didn't stop the video. Interesting.
Оно сохраняет в реальное время?
Not in real. Yes, it's the first frame actually, and after
Don't
that.
forget close capture in CV2 because it won't save your video.
Yeah. I know this problem. Yes, research object. What it will be? Actually, I wrote it already.
System of
System.
two values,
Yes, system. One slider.
horizontal.
It will be translatory motion.
Yeah.
Second, ball, rotation motion.
It's just like hanging with the string.
It's mаяк or маятник.
Inverse pendulum.
Inverse pendulum.
Like you broke inverse pendulum. It was
It's just common pendulum. Yes, I mean yes, inverse pendulum. Yes.
not fixed.
It's inverse pendulum if X Y. You see, I just
Ah.
No.
No.
it's pendulum, but it can move like this.
What is inverse?
Inverse pendulum is
Control key. You already know. Yeah, что же already know.
okay.
I know.
Probably you will use it. I know that Oleg Balakhnov made it in the lab for his purpose. So he made inverse pendulum and he checking this.
Маяк же какой-то.
Yeah.
No. You have moving gap.
So how many degrees of freedom? What?
They have the inverse pendulum.
You can use it for first learning to control it. I did the. Okay. Did you get what does that mean inverse pendulum?
No.
So you
То
have
есть штука
you have the slider there into D. So if you put like this, it will fall down.
Yeah.
But using
Yeah,
some code, I mean some control, you can do that. It will
Покажи,
be always...
пикам инверс K0.
Yeah. Inverse...
Yeah, I saw
Better
the
understand.
control theory.
Yes. Okay. So how many degrees of freedom do we have? So guys, we have 2 degrees of freedom. I hope you agree with me. Because it can move independently and this can move independently. 2 dov. If we see 2 dov, it means that we cannot use all our knowledge, previous knowledge except Lagrange or Newton-Navier.
No, we somehow solved it with Nikifor. So we can use our previous knowledge.
Yeah, actually yes, you can, but it will be very complicated instead of, or maybe you will make some assumption, really some assumptions.
Шиrini.
Yes.
And Nikiforov also.
Hello.
You assume this?
Is the reason why using Lagrange equation. Okay. After this, forces. Force analysis.
2 degrees of freedom.
Degrees of... You asked the question. Don't. Force analysis. Actually, we have only 2 weights. I mean, 2 weights. I mean, gravity forces.
Yes, to be honest, I still don't fully get what should we write in force analysis. Like in your solution, you just write mg. That's it. And underline it. And like I don't fully understand. Like,
If task is not solved by second Newton's law, you can stop.
Well, again, I think
we write like if you like I open your previous like for the boat, for example, force analysis, and under force analysis you write mg and that's it. Like
we have only so
Oh,
we
so
have. I know I wrote Archimedes force.
yeah, like example. So
Why I wrote just see? You need to write all forces which you have, or maybe
It's
I have
forces.
in force
You
analysis.
have forces and force analysis. Different.
like
In force analysis, it consists of force.
so
You write like search object, forces,
Forces.
initial conditions, final conditions, then force analysis.
Force analysis in this case, I draw a picture, for instance.
yeah, so I don't get what should be put under force analysis.
Because I am the
It should be a picture like
Yeah,
this,
yeah,
but
okay,
we
we
put.
did picture. The picture is okay. We drew all forces.
And
but what should-
we also need to write all forces. Why? Because in some cases you can. In this case, we know M. So actually it's just clear. But if we, for instance, have F resistance, do you remember from the V2? I mean, this one, when we have. In this case, we can write that C, for instance, V.
So definitions of forces that we might have.
It's force analysis.
Yes.
You wrote
We
it under
we
forces.
analyzing our forces.
You,
What we have.
I never saw under forces.
I just maybe on the first class, but actually after this I just wrote for force analysis
First
everywhere.
stuff under force analysis.
I wrote forces and force analysis and just the solution.
Okay, we wrote it. After this we need to choose generalized coordinates. It's quite important in this task. In our case, they already set it to us that it should be x and p. So x slider displacement. It will be body 1.
What if it's not obvious? How to choose generalized coordinates?
It's a creative part. On most of your tasks, I mean, at least on final this, it will be obvious. Like in manipulator and so on. In some cases, yes, it won't be so obvious, and you need to think even more in yo-yo. How many degrees of freedom do you have? It can be either 2 or 1.
6, because we are moving.
In 3D, yes, but you can assume that this oscillation is not important. If you say 2 degrees of freedom, and you can think, okay, it will be x, for instance, an angle. Or you can think, okay, so it's up to you. Or you can receive, okay, I have yo-yo in 1 degrees of freedom. I mean that it's correlated the rotation and translation. Because it's like the wheel
No sleep.
without sleeping.
We
Without,
assume no sleep.
yes. So, I angle of rotation. After this, in some case, they're asking you to do, in robotics, it's better to write kinematics firstly of your system. Now we need to, okay, I learned kinematic for 8 weeks. No, I mean for 8 labs, I can solve it.
And 2 more for the
Kinematics. We have first body x1 equal to x, y1 equal to 0, x2 equal to x plus L sine theta, y2 equal to L cosine theta. Is it clear? After this, as you remember, we need to work with kinematics, or not with with energy, kinetic energy. You need to know velocities. Take derivative. It will be there. So, velocities. x1 dot will be x dot, y1 dot will be 0, x2 dot will be x plus L, sorry for L cosine theta dot. But it depends on the, we put it on the basis. Now we need to find the final velocity. So, velocity 1 will be x square plus y square. It will be x1. v2 will be the same. The solution, I think you get it. We won't write the solution because we will put it later. So you made kinematics. And now we have 2 degrees of freedom, we have 2 variables. It's okay. Needed. Did you get what's going on there? Just the first, from the first part of the semester.
Yeah.
Ярик, все понял? Просто почитали кинематик. In manipulator it will be, actually we can represent it in Jacobians. Now we need to write kinetic energy. Kinetic energy is sum of kinetic energy of all bodies. It makes linear motion. It will be m1 v1 square full velocity v by 2. It's not x dot. It's full velocity. Yes, in the final case it will be x dot, but we need to write.
Okay.
What about the second one?
It's a complex one, but
No. Next body make rotational movement, but we can represent rotation movement also in linear momentum. I mean,
multiply by L.
MVR.
because we have a particle,
Кого?
we don't have inertia there.
Подожди. Там же
Inertia, omega square. How can you find inertia?
If we don't have
L-
MR квадрат.
M
MR
squared,
квадрат.
and omega is V over R, L.
Yes.
So they will cancel each other out, and we will be left with this stuff.
This stuff.
This stuff. Another.
When the 1/2 comes.
Yeah.
Yeah.
That's the question. Okay. Yorkshire. It's
After
it's
this,
square n
we put all our material, all our information.
over n. What? Square. Square.
How big is square? 1/2. Oh. Yeah, that's okay. It's just by definition.
I already simplified the equation.
Good for you.
Okay.
Actually, so what I did, I put our velocity there, and after this represented in such manner. What we need to do next? Find partial derivatives according to the equation. First of all, we need to find partial derivative according to x dot. I mean, first and second generalized coordinates. What it will be? Because of this guy, we put 2 there. I hope you remember how to make derivatives.
I hope you remember how to integrate, right?
Oh my! It's out of scope of today's class.
How to integrate? Yeah, we see.
So. See.
ABC.
After this, we need to find to x. It will be equal to 0 because we don't have x there. And for theta, it will be minus m2 L sine theta dot x dot. Whew. We completed the part of kinetic energy. Now we need to work with generalized forces. So be ready that it's not so fast even in midterm. As you may see, it's not so fast.
Give us more time, huh?
It was 3 hours, if not mistaken.
Could be 3 hours.
Yes, after this you will have oral exam. I didn't say it.
No.
No. Because if we have only 9 person, and in previous year it was the same, you have oral exam.
What do you mean 9%?
I mean,
With whom? With your Paletkin?
both.
Whoa. So wait, how much percentage do we have for the final?
20.
Okay, and
Easy.
What's the problem?
the oral will be like percentage or like?
You write what you will, what house look like. You solve tasks.
Okay.
You go to me and Paletkin, and you need to explain each task. We ask tricky questions about each task.
So easy grading for you. Just like, okay, you'll have your grade now.
And yeah, finally you will know your grade after this.
Good luck.
After this, we need to find как она называется?
Дельта.
Actually, what is it? We can find it in 2 ways. I wrote it in terms of just common job. I mean, when we need to find work. We know this potential energy. We can write it as potential. So we know that it will be 0 because delta H won't change. It will be according to x, but not according to y. So it will be 0.
1 minus cosine.
Бля, я не понимаю, откуда сигма-то берется.
Сигма 1 это кто?
What is the mean of this portion? Sigma.
This one? It's not sigma. I don't know.
Я
But
могу
it's
показать.
It's delta. It should be delta.
Это как буква Б, только наоборот.
It's delta. Then it's delta.
Да. Вот и вот такой завиточек. Нет, не так. Сейчас.
Piglet. Sleep as a pig.
Это я все время путаюсь. Типа, о,
Okay. Like
это
a
сигма, это
like a
дельта.
nota. Okay.
Да.
This термодинамика. Жизнь.
Easy.
The legend.
Easy. Okay. So, but we found a work, but not a generalized force. The equation of generalized force is following. I put it there. Where it is? This one. Actually, we can derive it actually with this one, but it's a work, and this one the last one.
Why is this L sign just L sign?
L sign. Because
It's changing x coordinate. I thought we considered.
so our u1 equal to 0 because of the first component.
Шиван entropy текста.
Наха Евгений.
And the final step is to put the to put the derivative. Or
Маленький мальчик, тут не
after this, you need to solve this task, and you will receive equation of motion. Especially, you may see a green part. So for instance, we have this side and the same to show that how we put it for you. So for instance, we have generalized force. It looks like this, and we put it there. Boom, boom. About second task, I also provided the link because we don't have time. It's a bit different task. So in this case, you need to find the center of mass acceleration. Okay. So
Center of mass.
So you have A because it rotates, and you have inertia. You want to find acceleration for some particular point. Its point is the center of mass of this body.
So find the acceleration of center of mass, and the center of the mass. Your English needs a bit work.
Actually,
Mine also.
you can
Shuffle some notes.
actually without off you can write like this. So
Where is the
if you
center?
want to drop a lot of off, because there will be acceleration of A over the center of
Find the acceleration of center of the mass.
you can drop off and put it on the left before.
No, it's not clear.
When I was in, we had American guy. He taught me the course technical writing, and he said us that it's one of the possible techniques.
He was
It
bald
works
guy?
in Russian.
What?
but not in-
Bald guy?
No, not both. It was
Хорош, блин, давайте.
okay.
Давайте смотрим.
There are two tasks,
Wait, we have another group task?
of course.
The last one.
I told you that you need to understand how to work with this. Otherwise, you will just drop because you don't know how to solve the.
You will not go.
Easy.
Да.
I see.
We can, how to say, actually according to the
Look at his boundaries.
No. You,
Then
no,
you know
no,
that.
no, you don't.
Don't worry, I won't do it.
No, you cannot do it.
I won't do it because my goal. I told you that
told
my
you.
goal. That you need to. My goal to, how to say, you need to suffer during the class, but you won't drop after the. So the first task is about how to say. It's about the energy. So make a plot and a question. This is a tricky question. Try to answer.
Question.
If we need the lesson.
That's one more task, that's it. What?
Трикутник.
It's Lagrange. So
Lagrange.
yes, find the equation of motion, simulate. So in this case, you need to simulate
А в
in
Яблонском тоже
GeoGebra.
Лагранж?
What?
А в Яблонском тоже Лагранж?
Yes, the 21. You don't have Lagrange in in English book.
For dynamics.
No, yes, in English book then
There is.
Lagrange.
But
No.
actually, like Jablonski is just questions.
No, he has example of solutions.
That makes
Yeah, it's not in the translation form.
No, they have sample case. Yes.
One sample.
Oh, I
In the
saw
real Yablonski
statics
also-
task. It was maybe not for dynamics, but
In real, in
It's
Yablon.
not
Statics
just
in
like
English
two-
version.
Something like this.
it was a solution.
yes, they provide
I have scanning